As we continue to explore derivatives, the next thing that you're probably wondering about is, well, we know how to find the derivative of a function when we have a sum or difference, right? What about product and quotient? And so that's kind of where we're going next. We'll do product rule in this video and then quotient rule next. But product rule has a nice geometric connection, and I'll explain it briefly, and then I'm not going to get into the details too much because the notation hurts a little bit. But the idea is that if we are looking at this rectangle, right? So we'd say, okay, so the base rectangle that we have would be this one rectangle that has, a height of v and a width of u, and so then the area of the rectangle would be u times v, right? But what happens if we increase it a little bit, increase this by, say, delta v, and then increase this by delta u, okay? And so that would be these lengths, these heights and widths as indicated, okay? Well, then our area changes, right? And so the change in the area UV, so our area would have been UV, and so we're looking at the change in the area. This would be computed, so the new area would be U plus delta U times V plus delta V. Okay, and then, so that's the new area, and then the change, well, we have to subtract the old area, right? The old area was UV. Okay, and so as you go through the arithmetic, this would simplify to U delta V plus V delta U, and then plus delta U delta V. Okay, and delta is just a symbol used to mean change in. Okay, now we're going to introduce a little bit of complexity. We're going to say, okay, that's how the area is changing, but presumably U and V are functions of X, right? It says that here. U and V are, let me undo that. U and V are functions of X. And so when I look at the rate of, or if I look at the change in U and V, naturally there's a change in X that's associated to them. So I would do change in UV over change in X, and then that's effectively dividing each of these by change in X. So U delta V over delta X. So I just have to divide each of the quantities by delta X, but I'm putting the deltas together, and you'll see that this is intentional. Let's see, this would be delta U, delta V, and since there's two of these involved, I'm just going to put it under both of them, okay? And then I'm going to just do dot, dot, dot. There's a little bit more to the story here, but what we have to do is then do like a limit as delta X goes to 0, and then what we end up with in terms of notation, this would be done through a limiting process. The left-hand side becomes d dx of uv, okay? And then the right side would be u times dv plus v times du, okay? This last quantity would actually drop out because of the limit. And so that gives us our first product rule, okay? I remember it a little bit differently. I was taught differently, and this is a phrase that it's stuck in my brain. Maybe it works for you. The oov minus voodoo, okay, that's kind of how I talk about it sometimes with students. The oov, the UDV, I remember as oov, and then voodoo, just VDU. I don't know why that sticks too, but I was taught that if you number your functions, f of x times g of x, right, they're multiplied together, but you can identify, this is the first function, this is the second function. Then I remember the product rule as take the first function, 1, times the derivative of the second, d2, plus the second function, 2, times the derivative of the first function, d1. So I remember it as 1d2 plus 2d1, okay? If that works for you, great. If you want to remember it as oov minus voodoo, sure, go for it. Or, f times g prime times g times f prime. That's fine. Okay, so we have some examples. I'd like you to try the first two on your own. So pause the video, try them, resume the video when you're ready to see the answers. And there you go. Okay, so what I did is in the first one for f, I just wrote that square root as x to the 1/2, and then I did my 1. So this is 1, and then d2 plus 2, and then d1. Okay. Same thing for g, right? I just wrote it in terms of negative exponents first, and then I did 1 d2 plus 2 d1. And certainly, like, you don't have to do it in this order. It's just, it's a mnemonic that is forever ingrained in my brain, and maybe it'll work for you, maybe it won't. Okay, so there you go. In this next example, right, we're given, this is called a sparse data problem. Okay, so we're not given the exact function, we're just given some pieces of data related to the functions that are hopefully pertinent. So here we have to do h of x, we have to find h prime of 2. Well, first step is find h prime, right? Oh, but we have 3 products going on. How do we handle that? Okay, so you know, look at it, stare at it, cry a little bit maybe, but what we end up doing is we can chunk it. Okay, so we chunk this, the x and f of x is, say, function 1, and then we have g of x as our function 2. Okay, and then when we get to the derivative of d1, that's when we have to do the product rule within a product rule. Isn't this going to be fun? Okay, so we do 1, so x f of x, d2, so times g of x, g prime of x rather, plus 2, so g of x, times d1. So now this is where within here I have to do like another 1 and a 2. So then I would do 1 times d2 plus 2. I'm going to move this up top here. Plus 2, which is f, d1, which is 1. Okay, that looks like a hot mess, but we got an h prime of 2, so I'm going to put 2 in everywhere. So it'd be 2 times, or f of 2 times g prime of 2 plus g of 2 times the quantity that is 2 times f prime of 2 plus f of 2. F of 2. All right, and I get 2 times, let's see, f of 2 is minus 2. G prime of 2 is 7 plus, did I do that right? No, I'm sorry, now I'm doubting myself. Yeah, yep. And then g of 2 is 4 parentheses 2 times f prime of 2, which is negative 2. Oh, wait, hang on. Oh, yeah, okay. Times negative 2 plus f of 2, which is minus 2. Okay. And I'm going to say a whole lot of arithmetic later. My final answer for this one was negative 52. Okay. Let's say I get negative 28, and then I get negative 4 plus, so that's be negative 6. Times 4 is negative 24, negative 24. Yep. All checks. So there we go. All right. So product rule. Yeah. We got a lot of practice with it today within this video. So again, 1d2 plus 2d1, that's how I remember it. But either way, just remember that you cannot differentiate each function and call it good. Okay, if you have a product in between two things and you have to differentiate that expression, you have to do each piece separately.